Hey everybody. All right, so here's this worksheet that you guys have been working on, and I know it's been challenging for a lot of you, and I'm trying to get you where you really recognize that that's not necessarily the worst thing in the world. I want you guys to get a little bit more uncomfortable with being uncomfortable here and there, but at the said, I also don't want to frustrate you like crazy. So here's what we're gonna do. I'm gonna go through this and just show you how to kind of set things up. Occasionally I'll refer to this worksheet here, which is a list of our equations. And hopefully you'll notice that I don't have the definition for velocity there, which is the difference, the change in x over time. I don't have the definition for acceleration there, which is the change of velocity over time, and that's because those are definitions and I think you should know them. But the rest of these I'll have available and we'll occasionally flip up to look at them. So right now I just want to kind of go through some of these problems and show you how to set them up. I know it's been frustrating, but the fact is, when I walked around and watched you guys work, and I know a lot of you guys are doing great work, and I'd want you to realize that you're doing awesome, and to not be so frustrated about things. So let's just dive in and see if I can help you figure out what we're supposed to be doing. All right, the first thing it says is we need to state the given and the needed information. So let's go to number one. Car in front of the school goes from rest, so that means that V initial equals 0 meters per second. And then it goes to 27 meters per second. That means V final equals 27 meters per second. We know this happens in 3 seconds. That means our time is 3.0 seconds. And now what are we being asked to do? We're being asked to find what is the acceleration. So A equals. So now what we do is we take a look at our formulas. Do we have anything that tells us about formulas? And again, we look up there and remember what I just said. Because acceleration is the definition, we know that it's the change in velocity over time. So in this case, A would be V final minus V initial over time. There is the formula that you'll use. And because we know the final velocity, we know the initial velocity, we know the time, we can plug these values in and solve. Now at this point, if you prefer to use the solve function on your calculator, you can do that. I think you should do the algebra first and plug the numbers in later. If you have questions about that, come see me and I'll help you out. Let's move on. Next one, a rocket starts from rest. What's that tell you? V initial equals 0. And it accelerates at a uniform rate of 190 meters per second squared. So acceleration equals 190 meters per second squared, and it does it for 2.4 seconds. So t equals 2.4 seconds. What is the final velocity? Well, let's take a look at our formulas. Got a bunch up there. What do we know? We know initial velocity, acceleration, and time. Which one of these uses initial velocity, acceleration, and time? And I think here, initial velocity, acceleration, and time will provide final velocity. Let's use that. So now you end up with Vf equals initial velocity plus acceleration times time. There you go. That's the formula you'll use. Again, you can use solve if you want. I recommend doing the algebra, keeping the units in until you find out if they give you the desired result. All right, moving on. Number 3, a car has a velocity of 15 meters per second, then it accelerates. So what kind of velocity is this if it starts at 15 meters per second, then it accelerates? That's an initial velocity, and it equals 15 meters per second. Then it accelerates at a uniform rate of 3.5 meters per second squared, so acceleration equals 3.5 meters per second squared, and it does it for the next 5 seconds, so t equals 5.0 seconds. What distance? So wait a minute, what's our abbreviation for distance? Oh yeah, the change in position. So we want a formula that gets us change in position in terms of V initial, acceleration, and time. What do we see? Change in position equals V initial, time, and acceleration. Hey, everything we need is right there. Let's use that one. Delta x equals V initial times t plus 1/2 at squared. And then you plug your numbers in, being very careful with your units and your algebra, and you should end up with the correct result. All right, you can always pause these and go back and check it out if you have problems. All right, things are getting a little hairier right now. All right, let's dig in. What distance? Okay, so we're looking for delta x. And then it is required for a train to stop. What does stop mean? Well, that means a final velocity is 0. If its initial velocity is 23 meters per second, v initial equals 23 meters per second. And its deceleration, hey, that's not a technical word that we like so much, but what does that really mean? It really means you've got an acceleration that's negative. It's slowing things down in this case. So we started with a positive velocity. If this is slowing it down, the acceleration must be negative. So it's 0.225 meters per second squared. And what are we trying to find again? Distance. Do we have a formula that gets us there? Well, remember we have final velocity, initial velocity, and acceleration. What don't we have? We don't have time. So if I'm looking at these, this equation needs time, time, time. This one doesn't. This one needs time. This one needs final velocity, initial velocity, acceleration, and delta x. Hey, final velocity, initial velocity, acceleration, solving for delta x. That's my equation. So we're going to start with this. Vf squared, your final velocity squared, equals your initial velocity squared plus 2 acceleration times the change in x. But we're solving for delta x. At this point, you could plug all your numbers in, and if you have one of those fancy calculators, you could hit solve and it'll do the work for you. However, I prefer to do the algebra, so I would rearrange it, and I would work this thing around until you end up with delta x equals Vf squared minus V initial squared, all divided by 2a. If you're not comfortable with that algebra, practice it. It's a really important skill, which is why you spend all that time learning it. Okay, questions so far on anything? Okay, moving forward. We're 6 minutes in. We can do this. 7 minutes in. Trying to get it done in 15. Number 6. A person starts at rest. Oh, wait. Sorry. Number 5. What distance, delta x equals something, will a car cover while uniformly accelerating from 12 meters? So we know the initial velocity equals 12 meters per second. That's there. To 26 meters seconds. So final velocity is 26 meters per second. And we know the time is 14 seconds. So right there. And we're trying to find the distance. So here we are again, doing this thing. We have VI, VF, we have T. We don't have the acceleration. So which of these can I possibly use up here? Well, I've got T, VI, VF. T, VI, VF. There's my acceleration. But I know that. It's not going to help me. This one is close. But, wait a minute, let's break into that term. So remember, if we do this, delta x equals v initial t plus 1/2 at squared. If we don't know the acceleration, what's another way to say acceleration? It's the change in velocity over time, correct? So what if we substitute that in? Delta x equals v initial t plus 1/2, and here we have delta v over t times t squared, because remember a is this. So we end up delta x equals v initial t plus 1/2 delta v times t, because one of these cancels with that. And here's your final equation. All right, what's the trickiest part of this question? It's recognizing this. You have an equation on your list, kind of looks like what we need. Sorry, right there, but the a wasn't there. So we recognized our definition of acceleration being the change in velocity over time, and we substituted in. That's the trickiest part of this problem. You might consider making another equation there that looks just like this one and adding it to your tool sheet. If you don't know the acceleration, but you do know the change in velocity, you can substitute that in. At this point, you should have these equations and anything else that's helpful in what we call a toolkit that you can access readily and look through your formulas so you can use them. All right. Come see me if you have problems. Moving on. Number 9, person starts at rest. V initial equals 0. And accelerates at a uniform rate, A equals 3.2 meters per second squared for a time of 3.0 seconds. It's all provided right here. What distance? Delta x equals, let me think, I have VI, sorry. I've got acceleration, I've got t. Which one of those can I use? There you go again. Delta x equals v initial times t plus 1/2 at squared. All right, that's your formula. Again, you can plug in and you can just use your solve function, or you can rearrange and do what you got to do. This one's pretty straight. Moving on, number 7.